And yeah, I can see that everyone see that now. All right. So today I just wanted to talk really quick about how to create your own custom operators, or how operators are actually created inside of RxJS. So what I've got here just set up so far is I've got this observable source, and an observable is just a series of events over time. What we have here is just shorthand for we get a value and we are logging it. Observables have another important way that you can subscribe to them that we're going to have to show later on, and I'm going to do it right now. You can subscribe either with a function, or you can subscribe with an object that has a next function that does exactly the same thing. There's also an error function in case there's an error that comes out of it. In this case, I know that this is not going to error, but I'll still put it in there anyways. And finally, there is a complete function that is fired whenever this whole thing is done. So if I was to put error done, we can see that it's going to go tick along, and then it says done. Let's make this a little faster. It's kind of slow. All right. It gets up to 9, so 0 to 9, and then done. And it's stopping there because of this operator. So what an operator is, as you see, if we go and we look at this, it says, oh, it's take, and it returns a type of monotype operator function. If we were to look at what a monotype operator function really is, we can see that it extends operator function, which extends unary function, which is just a function like this, but it's a unary function of observable to observable. So if I was going to write this out in a more human readable way instead of what we've got here, what that's going to look like is basically it's a type op function or something like that. It goes from A to B, and it would be source observable A to observable B is effectively what this returns inside of here. Now I have to pull in observable. Same exact thing is what this returns, but in this case, take always returns exactly the same type you're given, which is why it's a monotype operator function or whatever. So this would be like mono. Anyways, so that's just the TypeScript side of it. Not super concerned about that, but the important bit is that all operators return something that takes an observable of whatever and returns a new observable of something else. So these are operations. So we're transforming one set of events into a different potential set of events. So each observable represents a potential set of events, where you get your event here, and this tells us when the events are done. Now, I already have taken here, and I mostly just have it so we only have a finite number of these that are coming out. What I want to show you today is to try to implement like the simplest possible operator. And so the simplest possible operator to start with, to understand like how operators are implemented, would be a map operator. And as I stated before, map is going to, well, it's obviously going to take a function that we'll call it the projection function or something like that. Project, and it takes a value of t, and it's going to return a new value of r. T and r for results. And what we're going to do is we need to do something that when this needs to return an operator function from RxJS. And an operator function, again, is something that fits this shape. Source observable T to observable R. Import these. So this is what we need to return for our mapping function to work. If I just even came in and said this, observable, this return source, this would be like an identity thing. Like clearly this isn't right because it's upset that this isn't an observable of R. But I could make an operator as simple as just like the no-op operator. That's probably the simplest, but it doesn't do anything. It's not very exciting. So what we need to do in here is we need to return a new observable. And clearly it needs to be a new observable of R. So right now you can see our types are happy. I need to export this so we can use it. But it doesn't quite do what we would expect. And I'm not going to do test-driven development with this. I am going to show tests for this so we can make sure it's working. I'm not going to do test-driven development with this yet because I'm most concerned with everybody understanding what happens inside of an operator. So again, you have this function called map, and I'm going to bring it in here. Let's see, import map from map. And we can use it against our source. Maybe we just want to double numbers or something like that. Right now, it's not actually going to double numbers. It doesn't do anything. It's not letting anything through. And the reason it's not letting anything through is if we go and we look at our map function, we get a source, but we don't do anything with it, right? So we never subscribe to it. So clearly, we need to, inside of this, at least subscribe to our source. But then we need to do something to send values along. Now, I could just say, here's a value, and I want to send it through.
Ben?
Yeah.
So, sorry, just can you try to please cut your camera, because attendees say that the quality is quite poor with your screen. And can you please also try to enhance maybe the size of the code?
Of course.
Thank you.
Is that better? Okay. So I'm going to go inside here and just, if I can change the size, width of this a little bit. There we go. All right. So what we have in here again is just a function that this function returns a function that takes an observable and returns a brand new observable. And when we subscribe to that brand new observable, we need to subscribe to the source. So it actually connects it. And here we're not doing anything to it, right? Like we're just kind of passing it along. So this is just going to pump all those values through. You notice it's not saying done though. So that's one problem. Another problem is it's not applying our projection function. So if to apply our projection function, simplest thing would be right here. And apply project. Why is this angry? This is angry because I need to close it. All right. And let's run it. So here we actually are doubling what we're doing. So it's applying this function. So that's all good. So let's just say that we have this, and this is our super duper simple mapping operator. Now I need to test this thing somehow. And in order to test operators, what we have is this testing apparatus. It was designed specifically for testing operators in RxJS called the test scheduler. And I'm going to import that right now from RxJS/testing. And inside of here, I need to create one. So I'm just going to call it RxTest scheduler. And for each, need to create this test scheduler. So new test scheduler. Now, when you create this, it requires you to give it a function that will allow it to do a deep equals assertion, because what it's going to, what we do is we end up taking these characters that are called marbles and making them into arrays and then diffing the arrays between each other. So we take the actual and the expected. And in this case, because we're using jest, we just say expected to equal actual. And that's going to help us with our diffing. Now, the way that you use the test scheduler is you get in here and we say RxTest run. And this puts us in run mode. And what run mode does is a variety of things. For one, it hijacks any sort of scheduling that is default in RxJS. That's not something that I really want to concern everybody with right now. The biggest thing is it allows us to synchronously run things that pretend to happen over time with marbles, and it gives these utility functions to help us. So I could say expect observable here, and you can create like a test source observable by just doing this sort of thing like this. So if I go like that, what this means is 4 virtual milliseconds happen because this one represents 0. And then the the character A is emitted. Then 5 virtual milliseconds pass and the character B, and then 5 pass and the character C, and then 3 more virtual milliseconds pass, and then we complete. Now, the important thing to know is these are quote unquote virtual milliseconds, not actual milliseconds. These could be virtual years if you wanted to think of them that way. It doesn't really matter because it's not really happening in terms of milliseconds. It's just a relative thing. And if I was to take this and say, okay, well, my expectation is the same exact thing. See there, and then run expect observable source to be expected. This test should pass, and it should pass because, let's run the tests. Kill the console really quick. No, why is it not running that? Save it. So passing. And it's passing because these all equal the same. So, but this is, again, it's an observable of string is what we have here. And it's marked as a cold observable of string because there's some other properties we can use to check when we subscribe to it and when we unsubscribe to it. And I'll show that in a bit. But if I wanted to test my mapping function, I'll import my map operator, my custom map operator. What I need to do is I need to say, okay, well, given my source, here's some result. And we'll say source map or pipe to my map. And these are all strings. And if I was to do the exact same thing that we're doing elsewhere, where I'd say value plus value, I mean, it's going to concatenate strings together, but these are all single length strings. So if I test this, this is going to fail. And it's going to fail because it's going to say, like, I expected, you know, A, and I got AA, and so on and so forth, because this needs to represent something else. So I can go in here and you can map these characters to other values. So I could come in here and say, okay, A is 1 and B is 2, C is 3. And then this becomes an observable of number, you can see. And then right here, I can do the same thing. I can give it another dictionary of values. Only this time it would be A is 2, B is 4, C is, what am I saying? It's 6, all right? Now when I run it, it should be happy. No, it's not happy. Why is it happy? 2, 4, boom, 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 boom. It says it received 8 somewhere. Oh, here's why it's not happy, because I wrote it's saying it never got complete. So kind C means it was expecting a kind of complete, and we never got complete. What we actually got was this. So it's going to run and it's passing now, but that's not right. We want it to complete when the other one completes. So clearly there's something wrong with my map. And what's wrong with my map is I'm only handling nested values. I'm not handling what happens when the source completes. So this is not going to do. This is not, that's not going to be a good way to implement this. What I need to do is I actually need to use a function or a observer and also handle complete. And in that case, we just need to pass it along there. Now, if I run this, passing. So that brings us to the next bit. Like, what happens if, so this is just should work in a basic way. What happens if we take this and we want to handle an error? So it should handle erroring properly. Let's just say it gives us A and then boom, we get an error. And that's what this means. It means that we're going to have an error right there. You can even specify the type of error here if you wanted. It's like new error, bad, or whatever. It doesn't really matter if that's there or not. I guess I'll leave it. And I guess my expectation, and the nice thing about these marbles, by the way, is you can take these and you can line them up vertically to make sure they're happening at the same time. I in fact would even line these up a little bit closer. If I take this, let me just line this up here. I would expect this to have an error at exactly the same point. Like it should forward the errors along. If my source errors, I want that to be passed through my mapping function. So if I run this now, you can see that we have a problem, and it's that we expected an error and we didn't get one. So we didn't get an error because if we go back, we never handled the error mechanism. I need to take that also and always pass along. Run it. Oh. Because I did not pass the right type of error there, because down here in my test, I said, where is it? I said it has an error of new bad right there, but here I didn't specify it. So I need to specify that it gets the exact same type of error there. Now we should be okay. So we should be okay. It was just because this error was, wrong. It'll error if it doesn't match. So we'll have this bad there. So now we know it handles errors from the source appropriately. Now, whenever you're developing your own custom operator, one important thing to consider is if someone is providing, if external user land code is providing a function to you, it could error when it's called, right? And if it errors when it's called, in here, you're going to get some weird behavior. What you want it to do is you want that to also go down the error channel. So if I was in here and I said, all right, let's add a test for this. So I'll just copy this one again. And we're going to say that whenever the value is 2, because we know that's coming with the second thing right here on B, this is 2. If value is 2, throw new error. Oops. Right? So I would expect this then to error right here, and to error with new error. Oops. So it's getting here. This is just being highlighted by Code Sandbox, but it's getting there and it's sad. And the reason it's sad is it has this unhandled error, right? Which is why it's showing up here. And it's unhandled because what this is going to do is it's going to go in and it's going to say, hey, call this errors, and it just ends up getting thrown in its own call stack by RxJS, because this is not something that it's not going to handle it and send it down the error channel for you. So, and that's primarily because we can't have an observer that observes itself, right? Like it's not going to go to this function because you had an error in there. So what we want to do is we need to properly handle this. And so to properly handle this, what we do is just add our own try catch. So we're going to say let result r and then try result equals project value catch. If we have an error, send it there. Otherwise, send the result. So the reason that this part here isn't inside of this try catch is that whenever you're calling next, it's going to call a bunch of other code underneath it. If something in there is to error and you have it inside of this try catch, you didn't only catch the errors from your projection function that came from your user. You also caught errors that happened inside of here. This shouldn't error, but either way, it's a programming gaffe or gotcha. So I try to make sure I structure it like this. Now, if I was to run this code again, it should be happier. Let's see. it is saying that on frame 5, I'm having a hard time following this because the code is a little bit big, but let's see. On frame 5, we got the value of 2, and what we expected, or what we expected was undefined. Doesn't seem right. Let's go look at our test. So frame 5, get a value of 2. And we're saying if the value equals 2, we should error. Otherwise, aha, I didn't return. There's my problem. Now if I run it, it's happy again. So it was just I messed up my test. But the important bit is that now I'm properly handling errors that come from inside of this function. So I've tested this pretty thoroughly in most ways that I might want to test it. I might also want to add a test for, handling things like should handle never-ending observable source. You can just take these out of there. It should still be the same. Should handle an empty one. I mean, these are tests that you probably wouldn't do necessarily for map, but you might do for other ones. So you've got like this empty source where, this bit here doesn't matter anymore. Neither does that. But either way, they're all passing now. So that's kind of how you would go through and you would test a map operator. Now, it can get a lot more advanced than this. Like if you have something that expects you to do, like you're doing a custom flat map or you're doing a custom concat map or something like that, like then you're going to end up needing to actually do things like, come in here and say it. Just copy this really quick. Let's see. You'd have to come in here and where's the first one? First one's probably better. If you're going to test like a merge map or something, you would come in here and instead of having numbers in here, what you would do is you'd create like, other observables, cold, and then you'd say, okay, well, this is the one that's supposed to start here. So it's going to look like A or something like that. And B is going to be the one that starts here. Because the spaces don't matter. This is the only thing that declares time. Like this and this are the exact same thing because the dashes are the only piece that matter. So if I come in here and say, okay, then B does this and so on, you would just change this to be like, okay, this is A and this is B. And then C would be the same thing, except for I'm just going to delete C because it doesn't matter. So you would come in here, and if you're going to do a merge map, then this would give me an observable of observables, as you can see. So you could check like merge all or something like that. Map obviously doesn't get that advanced, but we can check that out in a minute. Let me take a break for a second and have a look at the chat. Let's see. So let's see. Can you use an RxJS operator in Ixgs? Is one question. I'll just go to the top. So what was what's the most complex operator you can create? The most complex operator you can create is quite easily group by. So if I was to go show you, and this is actually with a lot of helper code and stuff. Let me increase the size of this a bit. PS. Group by is very, very complicated. We add a lot of, I've gone through, especially recently, and added a lot of comments inside of here about how these things are, like why certain decisions were made in certain parts. But group by is incredibly complicated because what you have is you have behaviors where you're taking a single observable, subscribing to it, and then splitting it up into other grouped observables that are hot by nature, and they have to sometimes stay active even after the original source has completed, or even after the original subscription to the source. Rather, someone says, I no longer want to subscribe to this anymore, but they're still using the groups that it created. There's some real complexity in this. The easiest way to see which one's the most complex would be to go, just go through this and look at the ones that have the most code. This is by far one of the ones with the most code. Some of the other ones, let's see, the creation functions, I would say that probably combine latest is actually relatively complicated because of some of the stuff it does. You can just look at the types. There's tons and tons of types for this one, which we're weaning those down now. There's a PR for it, but this code makes it look relatively simple, but the best thing you could do to find out which ones are complicated would be to go and try to implement it yourself. but yeah, this one even has its own subscriber because of how ridiculous it gets in a couple spots. Zip is another one that can be pretty complicated, that sort of thing. Let's see, what's a notification? So a notification, quite simply, is actually, we were kind of looking at them here. If I cause one of these to fail, you'll see this thing right here. So you got this notification. It's an object that has an error, in this case, a kind and a value. And so the kind will be either an N for a next, an E for an error, or a C for a completion. Nexts will have a value. E's will have an error. But basically, it's this thing. It's not too dissimilar from an iterator result. Like an iterator result, you have done, which is a Boolean, and then you have a value. This is the same sort of idea in that it can be. It's a way to kind of hydrate, hydrate and dehydrate an observable stream. So let's say if I went back to my index here. I'm just going to do this. Now, if I was to go and say, let's materialize this. And then, I guess I didn't do that. What we're going to see is in our console, cannot set property below of an object that only has a getter. Why is it upset? I don't know why this is upset. It's upset because of the test suite. Let's just go to the browser. All right, so you can see here now I've got these notifications. And what you'll notice is for my complete notification, I actually have an event for complete instead of this. So I get an event for everything. Even if I throw an error inside of here, immediately, it doesn't matter. It's still, this never actually errors. It's guaranteed to not error after this point because this is taking any error that it would get and making it into a notification object and then nexting it out. So, and then of course there's the opposite of that, which is dematerialize. And that's going to bring it right back to where it was before. So if I say return that in there, I get exactly the same thing as I would without this code. It's just way more expensive because I'm creating objects and then no longer using them after this step. So there's a variety of reasons this exists. One of them is kind of like the testing use case that you saw. Another one might be to do some sort of comparison between two streams, which obviously is what the testing use case is. And the final one would be like, oh, well, what if I wanted to record an observable in a file and then somehow play it back, right? So you could materialize it, and then you could even go so far as to do like timestamp or something like that alongside of it. And you've got this value that's a notification alongside of a timestamp that you can use to kind of help play it back. So sort of an interesting way to use this, or you could add a performance now timestamp or whatever you want, but there you go. That's kind of what a notification is. let's see. Regarding as observable, Jan Nicholas said, in a talk, not using as observable on subjects leaves us with an anonymous subject, not an observable as a type. Is that a problem? So as observable, it exists for a specific reason, which is that if I was to go and say, create a new subject, subject and number or something like that. Let's just say I had some sort of system that was, or even let's just say we had like a class or something. And this is supposed to be private. If I have this in here and I want to expose this stream to people, if I just make this public, then anyone that creates a foo object can just be like, oh, haha, look at that. I'm subscribing to it. That's cool. But they can also now next on it. So you've kind of leaked an implementation detail, right? Like that's not what we want. So in order to prevent that, what we can do is we can just make this private and then say, here, this is public stream or whatever you want and equals this subject as observable. Now, if I have a foo, I can't next on that anymore. Like, why is it saying I can next? Oh, it's not allowing that. That doesn't exist on type number. Even at runtime, this wouldn't be available. All it's really doing is just kind of wrapping this subject in an observable. So it's not that expensive, but it's mostly just so you don't leak your subject as an implementation detail that this exists. So do you always have to do it? No, not really. Just if you're going to be exposing this subject as an API you only want people to subscribe to, then I would use as observable. If it's just in your own internal inner workings, and you trust yourself not to, use your subject incorrectly, then this is pointless. But if you want to expose the subject directly or the result of the subject directly as a stream, then as observable. Let's see. Can we use an RxJS operator in Ixgs? No, not really. However, one thing I can tell you is that in the current version, or the RxJS Next, the version 7, you can actually just convert any, let me change this here. I can go in here and I can say observable from, I can actually create like a async functions are in here and make an async iterable if I want. And then let's see, I definitely want to sleep. Sleep function there. I can say, await sleep. And yield I want to break my code sandbox on purposely typing that wrong and getting to it. Let's see, do something like that. It's upset at from because of that. So it's still doing that. Let me take the materialize and timestamp off there so it's more obvious. But what I can do now is I can, am I subscribing to this twice? No, I'm not. That was just old. So what you can do now is you can actually have this async iterable, and Ixgs is async iterable. So you can take an Ixgs async iterable and pass it into from here and use whatever operators you want on it directly. And all it's going to do is just iterate off of these in exactly the same way a 408 loop can. So yeah, so that there's that point. It only works in RxJS 7 and above, but it's there if you ever wanted to use RxJS operators on async iterables, which is what Ixgs has written around. Let's see. Do I think observable? Okay, so do I think observable is part of ECMAScript one day? It's getting more and more possible, and the reason for that is the existence of this thing right here, abort controller, and also abort signal. And the reason that this makes it more possible is because this is a cancellation mechanism. Much like when you subscribe, we're returning a subscription. Subscription is a cancellation mechanism, and abort controller and signal paired together are also a cancellation mechanism. And because this is now in every single browser and it's in Node as of Node 15, that means it's ubiquitous, and RxJS can start using it as a cancellation mechanism instead of subscription. Now, this isn't a change that we're going to make overnight, but it is a change that does need to be made eventually. And that means that if observables then are this type that uses abort signal, which it exists on all platforms, and we can standardize abort signal within JavaScript, then only observable itself needs to be standardized within JavaScript to get it to be part of, or within ECMAScript to get it to land as part of the spec. Prior to that, we needed to standardize observable, subscription, and potentially subscriber as well. But there's a pathway forward now where we would just use a standardized cancellation mechanism, which now there is a de facto mechanism, and which still needs some improvement. And I'm working with some people on the committee, various committees about that. But if we can get that standardized, then the pathway to getting observable standardized in ECMAScript is much, much faster. The current proposal has not been shot down. It is simply stalled, and it's stalled for a variety of reasons, not the least of which is the champion for it was at Netflix and left Netflix. And it doesn't have a champion, but it doesn't have disinterest, I'll say. Like, nobody on any of the committees is like, no, we definitely don't want to do this. Especially given how popular the library has become, or especially how do I say this? How popular RxJS and other types like this have become. Observables exist in many, many, many different libraries that are very popular all over in a variety of forms, but they're all the same concept. And so there's a lot of evidence now, more so than there was even 6 years ago when this started, that observables are something that the community wants and needs and uses quite frequently. And, in light of that, that's why they're not just straight up shooting it down. But it would be great if we had some of the minutia around observable, like a cancellation mechanism, finalized before you even had to go after observable. So do I think it'll land in ECMAScript proper? My answer is yes. Do I think it'll happen fast? My answer is no, because those committees are very slow. But this is the most optimistic I've been about it in a very long time because of abort signal and cancellation standardization. Let's see, are marbles the best way to make, okay, so marbles are not always the best way to make a unit test around an observable, to be honest. You can, if you are testing, let's say a component or something that takes my component, and it has some whatever, like in Angular, you probably are injecting something that is like a service. So you'd be like inject, so got some service, and the service is some interface shaped like get data observable. I don't know, let's just say it gets a bunch of numbers, right? So if you've got something like this, then what I would attempt to do in order to do this would be to create like a test and say, all right, well, whenever I inject this service or however I go about doing it, you want to say that you have like mock service data and just have it return subject, right? Because if you have a subject in there, if you have a subject in there, why is this complaining? Oh, because I didn't put an equal sign in there. If you have a subject in there, then in theory, anything that you get off of this inside of your component, you can just say data subject next, and then here's my data, right? And then you can assert right afterwards, like what happened in there. And this gives you total imperative synchronous control of what this is doing. Now, the only time this gets complicated is if your mock service has some sort of like delay or something like that in there. If it does have a delay, you can actually do all this stuff inside of this run mode, or you can just pass a test scheduler to it, and that allows you to occasionally flush the test scheduler with like rxtest flush or whatever that says, oh, anything that you've queued up, go ahead and like any sort of delay you've queued up, go ahead and flush that out and make sure they all happen in order. But that's the only place where it gets a little complicated. Otherwise, if there's nothing like that in there, this is a fantastic way to test stuff like this because it gives you 100% control of these things. Now, you could similarly, do a thing where you're like, okay, we'll put this in here, and instead of doing a data subject, I'm just going to say, here's my data stream, and it's going to be a cold observable of this. And it's expecting you to make it easier on myself. It's expecting you to do that. So I have this data stream there, and then we don't have to do that bit anymore. And we would just test our component to verify that at certain points, these things are happening. And you can do that. You can execute things at certain points in time by just scheduling them with, okay, at whatever this point is here, there's a time helper for that. You can say first action. Don't quite understand why this is formatting that way, but okay. The first action should happen like right after this, right? That's when we want to do this test. Put it there, and we say, oh, sorry. Right there is where this is going to take place, this bit of code, and you can in here, expect whatever component, to be happy or whatever you want it to be. But that's roughly how you'd end up testing something like a component that, if you wanted to use a marbles to do this, and you do this, you could do the same thing with a subject. Marbles do make it a little trickier though, because like this here represents what, 10 virtual milliseconds. Nothing's really going to happen in 10 milliseconds unless the flash is your user. So this gives you other mechanisms, like you can go and be like, okay, and it's a little wonky, and we have plans to make this better in a future release, but you can say, okay, so at about 99 milliseconds plus 1 makes this at 100 milliseconds. This is going to happen. And then that means that you probably want to do exactly the same thing, plus, a few more milliseconds before they click something else, or even, this. But the problem with this is 0 plus 99 plus 1, 2, 3, plus 99 again, plus 1, 2. So you have to do a lot of dumb math in your head to figure this out. And that's just the way that it's engineered right now. And we have plans to improve this quite a bit, but it does at least give a mechanism to do longer amounts of time, like an hour or something, if you have to. And again, since space doesn't really matter, you can kind of balance things out that way if you have to. But there's a variety of ways to test this. And just marbles, this isn't always straightforward, where sometimes using a subject is easier. So hopefully that answers that. Is there a tool that keeps track of active subscriptions? I know that Nicholas Jamieson is working on something for that. Right now, we don't have anything directly. The best thing that you can use is honestly just profiling and checking subscriptions. But it's the same problem that every API has that requires you to remember to tear down. The only difference is at least they're all the same shape in the case of observables. We have discussed adding some hooks or some event points for when subscriptions are created and when they're torn down. But for right now, the best tool is honestly just memory profiling in Chrome. So, see, I have written, we have never taught people how to write readable code with RxJS. What's best practice to deal with RxJS? So, one of the better things you can do with RxJS whenever you're dealing with trying to make code readable is, first of all, like whenever you've got like piles of operators, if you got like a lot of operators, like you're doing a take and then a map and then a merge map and then whatever, you can like make this more readable by literally just taking that out and being like, okay, so take 10 and double it. And, this is just as an example. Expects an observable number and source pipe, boom. And I can do that. And why is this complaining? It's complaining because it's saying it's unknown. Should not be unknown, but okay. Sure. Oh, it's unknown because I didn't import that. So we can do this, take 10 and double it, and then literally just pass it in there. And now all of a sudden, we know that that's the case. If you would like it to be more configurable, you'd be like, take and double it, and then this is the count. Right. I would go so far as to make it even more readable. Take count. There. Right. And so now we've got this bit here where if someone's reading through, they can be like, oh, well, this clearly takes values and doubles it or whatever. The other thing is, and this is with any code you write at all, you'll see in like whenever I was in group by, for example, which is really complicated. I've added a lot of inline comments in here, right? A lot. This is probably, it's kind of useless to me right now, but somebody else that comes along, like they might be like, oh, they're already bamboozled by the other code that's in here, and they hit this line of code and their brain is just like, I'm fried, I can't think about it. This is just to help guide people through stuff about, most importantly, why we're doing something here, right? Like somebody else might come along and be like, why don't they just use as observable? Well, guess what? Now you know, because like we had the foresight to add really detailed comments in here about why we're doing something. And this should be in all your code. This shouldn't just be like, there's no such thing as self-documenting code, to be quite frank, is bullshit. Like there's no such thing as self-documenting code. So if somebody ever says, oh, if you had to just name that function right, you don't need documentation. No, they're wrong. You should always go through and add documentation about what everything is and why it's there and so on. Like this is the number of items we will take before doubling them, right? And then when someone's using this thing, you can go here and they should be able to see, well, in Visual Studio Code, they would be able to see what it is and why, right? So it's important to add this sort of documentation. It's important to add inline documentation about why you're doing things. And this is a hallmark of, like, you could be the most junior developer in the world. And if I see you doing this, I think to myself, here's somebody that actually knows what they're doing. And you don't want to just say what it's doing. Like, if this is a comment that says complete the group, that's useless. I can look right here and see, oh yeah, you completed the group. Like that means nothing to me. I want to see why we're completing the group or why we're doing X, Y, Z here. So real important. Let's see. The difference between switch map, merge map, and concat map. So really quick, because we don't have a whole ton of time, the difference between merge map, concat map, and switch map is this. Given an observable that we're going to map, actually, here's what I'll do. Go up and just wipe out this whole thing. Up to here. I'm going to say, here's my source. My source is interval of 1 every second, and then we want to take 3 of those. Then we'll start off with merge map. So that gives us a number. And if I was to send that into interval of something shorter, I take, let's see, 5 of them, and we'll map it so we actually can see what that is, which is what we've got n there. We'll just call this outer. The inner value, and we'll map it to outer, inner. It's really broken now. I've locked up my, oh no, I've locked it up. No. Will it ever come back? Let's see, I'll refresh the page. Watch out to type all that stuff again because it didn't save. Womp womp. Well, that's eating one of my cores. I'll go over here. All right. So here it's outputting these things. And in the case of a merge map, which fresh, that's still too fast. Let's see. Oh, because we're only doing take 5. We're gonna have to do like take 20. You can see in the case of merge map, it's mixing those together. So merge map is saying, okay, so for every value we get of this, map it to a new observable and subscribe to it immediately, and then take all of those values and send them to the outcome, which is our source here. Like that's what we're emitting. Now, if I was to switch this to concat map, what that means is that we're only going to do one at a time. And as soon as it completes, then we move on to the next one. So even though this had other values arrive to it beforehand, it's going to run them one after the other. And then you see it goes to 19 on every single one of these before it moves on to the next one. If I do switch map, the difference is it goes right up to the point until it gets a new one, and then it switches to that new one. It unsubscribes from the previous one implicitly and says, okay, let's, so it only made it to 8 here, and then it takes up the 1, made it up to 8 there and said, no, I got 2 now. And then it finished that one because that was the last value that it got. So that's the big difference. In marbles, the difference is effectively like, you know, merge map is going to be A, B, C, A, B, C, A, B, C, or whatever out. And concat map is just going to be the A's. and then Bs, and then Cs, and then done. And then switch map is going to be A, and then, oh no, I got A's for a little bit, and this is not one-to-one with this up here, but A's for a little bit, and then, oops, nope, I got B, so switch to B right now. No, I got C, and then C forever until it's done. So switch map and concat map are one at a time. Concat map will ensure that you get all of the values. Switch just says forget it. If you are using this in something like Angular, I would say most of the time you want to use concat map. You do not want to use switch map unless you're only doing like an HTTP GET. If you're using it in Angular with HTTP in particular, you probably want concat map. Otherwise, if it's just a GET and you don't care if the results come back or not, then you can use switch map. But and then merge map you almost never want to use because it doesn't ensure any sort of order. Let's see. I think that's all the time I have. I'm going to answer one last question. So when building custom operator in projects, when is it a thing? So honestly, the number one best way to build a custom operator really is to not build one because odds are like there's so many operators that already exist in RxJS. You can probably just compose a few of those together and get the behavior you want. There are cases where you might need to build your own for performance reasons, or you might need to build it because you can't compose them. But realistically, like the example where I was like, whatever, I was like, okay, take and map or something like that. That's what you would do to make your own custom operator, and you would build whatever it is you're going to build like that, and like you would just use this take and map operator. That's a totally valid reason to do it. I recommend doing that, in fact, because it can help with code reuse and code reusability. It's one of the beauties of functional programming. So the best possible way is to try to build your custom operators off of existing operators. Then, barring that, there are certain situations where you need to create your own custom operator. When you do that, you would want to test with, exhaustively test with marbles and make sure it handles errors properly and all of that stuff. But for the most part, you want to build it from existing things. Let's see. Love to see a demo. I'm sorry, I don't have time for that. But I mean, it's the same as hunting down pretty much any memory leak. Like the things that are going to leak in RxJS aren't necessarily subscriptions. I don't have an app that's running in such a way that I could really, I don't think I can profile this as directly in a way that I can share the screen. But what you would end up doing is you'd go up under memory and you'd take a heap snapshot and you would find subscription objects under there. And especially if you do that over time, you can see how much it's growing, and you can identify like, oh, this subscription is growing over time. And then the thing about the subscriptions is they're usually also subscribers. So what you'll see is like a growth in map subscribers or a growth in take subscribers or something like that. Honestly, it's probably easier just to go through your code and look and see where you're not unsubscribing from subscriptions. Like you would grep for a subscribe call or a to promise or something like that. And don't use to promise, but if like anything that causes a subscribe under the hood, you would see leaks in there. You're not going to find leaks from RxJS operators themselves. We test for that pretty thoroughly. What you will see is leaks from your own code where you've subscribed and you've forgotten to unsubscribe, that sort of thing. And a combination of searching for your subscription code and making sure that you're unsubscribing versus actually digging into memory profiler. Those two things together are probably going to be how you're going to find the bug. The other thing too is like really obvious thing for me, but not so obvious for some people. If you're in here and you're like, I'm subscribing, like inside of a map function or something, yeah, that's going to be a memory leak because you did nothing with this subscription that you got back. Even if you were to return it somehow, or like it's this, like you've got something wonky going on in there, and you don't want to subscribe inside of callbacks to operators like map or merge map or whatever. I see that constantly, and it's a bad pattern. So the thing to look for is where you've called this. And if you've called this somewhere where you're not actually capturing the subscription and doing something with it later, and it's not at a top level like this, like here, I'm not capturing it because this is the top level. This is my program at this point. But if I was inside of a program where something, this might need to be torn down at some point, I would definitely capture this and make sure that I called unsubscribe on it at some later point. So I would grep your code for that if you're experiencing memory leak problems. All right, so I'm going to stop my screen share. Turn the camera back on.
Okay. Maybe if people have a question for you, what is the best way to reach you?
I try to answer everybody's questions if they DM me on Twitter. I really do. Sometimes it takes me a while because I get backed up. I'll get a lot of questions from people, but yeah, I always try to respond to direct messages on Twitter. My email, do not try to email me, even though it is up on GitHub. You try to email me, it will just go into a black hole. I will never see it. So, but yeah, DMs on Twitter.
Okay, thank you. So thank you again, Ben. It was very interesting.
I'm glad. Hopefully that helps some folks.
People in the chat, people seems to be happy.
Thank you again.
Thank you. Bye-bye.
Bye-bye.